Hi everyone. Okay, so next lesson here is going to be on altitude and azimuth, and then we're going to have a little project on this too, which hopefully you'll enjoy. So first of all, on your sheet, there's nowhere actually that defines altitude, so you're gonna have to add this in. So just put it at the top. The notes that we're using right now are the ones that say using your hand to predict altitude. So right at the top somewhere, I just want you to write down the definition of altitude here. So the altitude is the elevation of an object above the above the Earth's surface. So this diagram here shows it. And don't worry about azimuth, we'll talk about that after. But the altitude, so this is a pencil, right? So this would be like you had a flat surface here. This is just the table. And if you have your pencil tilted up, the angle that exists here, how far that tilt is, this here, that is going to be the altitude. So how far that is raised up. This is obviously on a very small scale. We can take this on a large scale. Say we had a bird in the sky or a tree. Let's do a tree. The altitude of the tree would be, this is the earth here, right? So this part here, that is the altitude. And some of you who have, you may have seen this in math already, right? Where you're using Pythagoras to solve for the heights. But now we're actually going to be calculating the angle here. So this here, this is the altitude. So how high something is above the Earth's surface. Now we can extend this, of course, to the sun, our nice green sun here, and that will also have a certain altitude associated with it. Now, if we were in class, we would have built what's called an astrolabe to figure this out. So an astrolabe is a device that you can use to help you measure the angle. But because you're all at home right now, we're not going to build it, and instead we're actually going to just use our hands. And using your hand works pretty well, oddly, for predicting certain angles, especially for celestial objects here. So we're going to use our hand to predict altitude. So what you do is you hold your hand out in front of you. So right now I want you to hold your hand out in front of you. Now I want you to put your palm so that hold your right hand out in front of you. Now put your palm so that it's facing, or put your hand in so that the palm of your hand is facing you. So you kind of got your hand bent towards you. Now hold your fingers in except for your pinky. If you hold your pinky out, that represents 1 degree above the earth. So if you find something, you could line it up in your sight line. That's 1 degree. 3 fingers together like that represents 5 degrees. There's our 5 degrees. A fist together is 10 degrees. Your second finger to your fifth finger is 15 degrees. Now on your notes there, you have an extra one where 2 fists together are 20 degrees. And then if you stretch your thumb and your pinky out as far as they go, that represents 25 degrees. So we're going to use that method to predict the altitude. Now, tomorrow, it's at night here. Tomorrow I'm going to actually make a video showing how to do that, because I think this may confuse some of you guys. So I'm going to make a video and I'll post that also on the website. So look for that video that I'll post. Now, this is an example of her doing it. So this woman here, she's got her hand fully extended. So she's got the thumb to the pinky. So that is showing 25 degrees. So what that means is this angle here. So this is my line here. This angle is 25 degrees. And so if you were holding your hand straight up, if you were looking, that means this way. And then up top, say you had an object here, this angle here, so that's your 25 degrees there. So this is how this works. Okay. Azimuth. So copy down this definition in red here. So azimuth is the compass bearing relative to true north of a point on the horizon beneath an observed object. It's kind of a mouthy Mouthful of words here, definitions. I'll explain it once you get that copy down there. So basically, this is just using a compass. So how far off of north something is here. Oh, shoot. Sorry, I just looked at that. I'm going to change these directions here. This is showing the diagram I picked. It was not a good one. Basically, north represents 0 degrees, east is 90 degrees, south is 180 degrees, and west is 270. And we know that because how many degrees make up a full circle? Yeah, 360 degrees make up the full circle. So we divide that into 4 quadrants. Were you guys taught how to memorize the order? I was taught never eat. So north, never eat soggy wieners was what I learned. I'm not sure why soggy wieners are bad, but whatever. So the azimuth is how far off of north something is. So if we look at this one, you're looking here. So the 0 degrees would be true north. So directly north overhead would be 0 degrees. Now, the sun is clearly not, I'm going to switch to a different color here. The sun is clearly not at exactly 0 degrees. It's over here, right? So we have to move over, and then where that is right about there. So that, how far off this is that level there. So that is going to be how many degrees off of north it is. Now, if east here is a full 90 degrees, this looks a little bit over half. So it's probably somewhere around maybe 60 degrees. But you would need a compass to figure that out. Now, luckily, we have compasses on cell phones. So if you have some kind of a device, or maybe you have a real compass. If you have a real compass, that's great. But well, honestly, the cell phone compasses are more accurate, I find, than the magnetic ones that you can get. Interestingly, so if we look here, so this compass, you haven't. There's an app for it, so try to see if you can get an app for a compass. I think it standard comes on phones, but you may have got rid of yours. You're going to hold it flat to calibrate it. And then it's always going to give you a reading like this. So this is 37 degrees northeast, as an example here. So you can find any object. You're going to point your phone at holding it with palms flat. You're going to point your phone at whatever object that you're looking at, and then you're going to read the compass bearing off of it. Now, I don't actually need the northeast part of it, but you just need the degrees. So you would write down 37 degrees for this one. And again, I'll also find a little video on how to do this so that you're not confused. Okay, so you've got to have 2 skills to complete this project. You have to be able to find the altitude using your fingers and find the compass bearing, or what's called the azimuth, using a phone compass. Okay, now your project, celestial observations. You are going to be observing the moon over the next 14 days. So you can start this whenever you want. You just need 14 days in a row. So don't leave it too long, obviously. So ideally, you would want to be starting it this weekend. So you are going to need to look for the moon every night, and you're going to take its altitude, so how high it is in the sky, and its azimuth, so the compass bearing at the same time. It's important to take these readings at the same time every night because the moon is going to move throughout the sky, throughout the night. Now, as you can see, this is a calendar. This is not the month that we're in. It's just an example showing how the moon is going to change over 14 days. So say you started on the 15th. If you go 14 days, you're going to go to the 29th, and you are going to see those different phases of the moon, ideally, hopefully, as you go through. So every night you are going to take its altitude, and you're going to find that using your hand. You are also going to take the azimuth using your compass, and you are going to make a sketch of what the moon looks like. So you're going to show it, and you're just going to draw it by shading in. You're going to do that for 14 days, and then you're going to graph your data, and we'll talk about that more a little later. So you all have the sheet for this. So I'm going to need you to read through it. Just pulling mine out here. So I'm going to need you to read through it, and then on the back of it is where you're going to write your information. So it says date and time of observation, the altitude of the moon, the azimuth of the moon. In terms of percent illumination, you're going to estimate that. And illumination means how much you can see. And then you're going to draw the moon's appearance. And then, oh, you know what? Those last two columns should have been deleted. So you can just scratch out those last two columns there. You don't need them for the altitude of it blank there. That was for something else. Okay, so you're going to do that. And then I was going to say something else. What was it? Oh, so certain nights, unfortunately, you won't be able to see the moon. So if it's cloudy, you may not be able to see it, or for other reasons as well. If that happens, you're just going to write that down. So you would just write and indicate that it was too cloudy, I did not see the moon. I actually did this project one year with a class of grade 7s, and it literally was cloudy for 10 of the 14 days. It did not work at all. So hopefully we will get some clear, nice weather where you can always locate the moon in the sky. If you happen to forget, if you miss a day, just try to get the data from someone that you know in the class, a friend in the class, okay? Okay.